Right now, you are participating in a catastrophic global biological experiment.
Yeah, and you never actually signed a waiver for it.
Exactly.
Yeah.
There is no control group left to compare you against. And, the variable being manipulated is the one thing biology demands we never ever mess with.
Your sleep?
Your sleep. Welcome to today's deep dive. We're getting into something that affects literally every single person listening. And it's honestly terrifying when you look at the numbers.
It really is. I mean, it is the absolute definition of an unregulated public health crisis.
Yeah.
We are universally truncating this physiological mandate that took, evolution millions of years to perfect.
And the scale of the data we have on this is just staggering when you look back even just a few decades. Like in 1942, Gallup conducted a poll on sleep habits.
Right.
At that time, only about 8% of Americans were sleeping fewer than 6 hours a night. 8%. If you were surviving on 5 or 6 hours back then, you were a complete statistical anomaly.
Which is wild because today that figure has skyrocketed to approximately 30% of the population.
Almost a third of us.
Yeah. Nearly 1 in 3 people you walk past on the street is surviving on less than 6 hours of sleep. The average adult is now getting about 6.5 hours a night.
Meaning we've systematically shaved an entire hour off of our nightly biological recovery time in just, what, a couple of generations?
Exactly. And we've done this while simultaneously increasing the cognitive and psychological demands of our waking lives.
Right. We're demanding way more of our brains while actively depriving them of the physiological resources they literally require to function.
So our mission for this deep dive is to completely dismantle that I'll sleep when I'm dead productivity culture.
Oh, I hate that phrase.
It's everywhere, though. The glorification of overwork, the whole celebration of the 5-hour night, these are biologically illiterate concepts.
Okay, let's unpack this, because I want this to be the ultimate shortcut for you to understand your own mind and body. We're going to prove that sleep isn't some passive luxury you can just trim down. It is the foundational mechanism for physical and cognitive survival.
And I think the first hurdle we have to get over is completely reframing what sleep actually is.
Yep.
Because, culturally, we tend to view sleep as a powering down phase.
Like closing the lid on a laptop.
Exactly. The laptop analogy is perfect. You go into standby mode, the screen goes black, nothing is happening, and you're basically just saving battery until the morning.
Which fundamentally misrepresents the neurology of what's happening in your head.
Oh, entirely. If you actually look at an EEG of a sleeping brain, it is an extraordinarily active state. The brain and the body are performing these complex functions that simply cannot be performed while you are awake.
It's a universal mandate, right? Like every animal does this.
Every single animal that has ever been studied by science sleeps or enters a deeply sleep-like state. There are absolutely no exceptions in the animal kingdom.
And the sheer variety of how different animals pull this off is fascinating to me. Like the African elephant, they only sleep for about 2 hours a day.
Right. They're on the extreme low end.
Meanwhile, the little brown bat is logging roughly 20 hours of sleep a day, just massive amounts.
And then humans sit right in the middle. We require a solid 7 to 9 hours for adults.
With teenagers needing 8 to 10 and children needing even more. But from a purely evolutionary standpoint, sleep is kind of a massive design flaw, isn't it?
Well, it's certainly the most dangerous thing an animal can do. I mean, think about it. You are unconscious. You are completely unaware of predators.
You're just lying there in the wild.
Yeah, you aren't foraging for food. You aren't reproducing. You aren't defending your young. It leaves you entirely vulnerable to the environment.
So if sleep were just this casual resting state, evolution would have found a shortcut.
Oh, 100%. The selective pressure to eliminate such a massive vulnerability would have bred it out of us entirely, millions of years ago. Because the risk of being eaten is just too high.
The fact that evolution has preserved sleep across all those millions of years, across every known species, despite the immense physical vulnerability it causes, that tells us something huge.
It tells us that the benefits of sleep must be astronomically high. The metabolic payoff just completely outweighs the threat of predation.
Okay, so if the brain isn't just powering down, what is the actual architecture of that active state? Because we know it's not just a uniform block of nothingness for 8 hours.
Far from it. It is a highly intricate 90-minute cyclical dance. Your brain shifts through these distinct phases throughout the night.
Mainly NREM and REM, right?
Yes. Primarily non-rapid eye movement or NREM sleep and rapid eye movement or REM sleep.
Let's start with NREM. This takes up the bulk of the night, right? Something like 75 to 80% of our total sleep time.
Exactly. And within NREM, you have different stages, but stage 3 is the really critical one. It's often called deep sleep or slow wave sleep.
Slow wave because of what it looks like on a monitor.
Yeah, if you monitor the electrical activity in the brain during this stage, the fast, chaotic brain waves of wakefulness are replaced by these massive, synchronized, slow-moving waves.
It's like hundreds of thousands of neurons are firing in perfect unison.
Firing, then pausing, then firing again. It's incredibly coordinated.
I always picture the brain during this phase like a busy office building.
Mhm.
During the day, it's chaotic. You're taking in sensory data, learning things, stressing over emails. You can't perform heavy structural maintenance while all that traffic is moving through the halls.
That's a great way to think about it.
But in deep NREM sleep, the traffic stops. The workers go home. And the overnight IT maintenance and physical repair crew finally gets to come in and do their job.
And that biological repair crew is incredibly busy.
Yeah.
During that specific slow wave phase, your endocrine system undergoes a massive shift. The body releases a huge surge of growth hormones.
Physical repair.
Huge physical repair. Your immune system also goes into active maintenance mode, producing infection-fighting cytokines. Your actual physical cells are repairing themselves from the oxidative stress that accumulated during wakefulness.
Okay, so that's the NREM repair crew. Then we have the REM phase, which makes up the remaining 20 to 25%. And this is the stage associated with dreaming, right?
Yes, vivid dreaming. And looking purely at the physiological markers, REM is intensely active,
Like almost awake active?
sometimes more than awake. If you look at an fMRI scan of a brain in REM sleep, certain regions are actually up to 30% more active than when you were completely wide awake.
Wow.
This is the phase where emotional memories are processed and regulated. Your brain is forming creative associations, actively colliding these disparate pieces of information you gathered during the day to try and find hidden patterns.
So your brain is basically a supercomputer running simulations while you dream. But physically, what's happening to the body?
Well, while the brain is firing on all cylinders, the physical body is completely paralyzed.
Wait, literally paralyzed.
Literally. A mechanism in the brainstem sends these powerful inhibitory signals down the spinal cord, and it actively paralyzes your voluntary muscles.
Oh, so you don't jump out of bed and run into a wall while you're dreaming about being chased.
Exactly. It's a brilliantly designed safety feature, so you don't physically act out the intense motor commands your brain is generating.
Okay, but here is where the math of sleep deprivation gets incredibly punishing for people. Because those 90-minute cycles of NREM and REM, they are not distributed evenly across the 8 hours, are they?
No, they're not. They are highly asymmetrical. In the first half of the night, those 90-minute cycles are heavily weighted toward that deep, restorative NREM sleep.
So you're getting the bulk of your physical repair done early on.
Right. But as you cross into the second half of the night, and particularly into the last 2 hours, the pendulum swings completely the other way. The cycles become heavily dominated by REM sleep.
Okay, so if I connect this to the bigger picture for you listening right now, if you decide to wake up just 2 hours early to get a jump start on emails, you might think, well, I only lost 25% of my sleep.
But that's the trap. Waking up 2 hours early doesn't mean you lose 25% of all your sleep types evenly.
Right.
Because REM sleep is concentrated at the very end of the night. Cutting your sleep short from 8 hours to 6 hours means you disproportionately slaughter your REM sleep.
Slaughter is a strong word, but it's accurate.
It is. You might lose 50 to 60% of your emotional processing and creative association time, despite only cutting your total sleep duration by a quarter.
Which is terrifying. So
Right.
what actually happens to a human brain when it's forced to operate on that 6-hour schedule day after day? Because a lot of people do exactly that.
We have to look at the landmark psychomotor vigilance research conducted by David Dinges at the University of Pennsylvania to answer that.
This is the 6-hour delusion study, right?
Yeah. Dinges wanted to measure the precise cognitive cost of mild, chronic sleep restriction. So he tracked individuals who were restricted to exactly 6 hours of sleep a night for 2 weeks.
Which, again, 6 hours sounds like a standard Tuesday for millions of working professionals. It
Well,
doesn't sound extreme at all.
It sounds completely normal in our society. But the objective data is just terrifying. Dinges utilized a highly sensitive reaction time test to measure lapses in attention.
Like microsleeps.
Yes, microsleep.
Oh,
These are moments where the brain simply stops perceiving the outside world for a fraction of a second.
just a total neural misfire.
Exactly. And what he found was that after 10 days of 6 hours of sleep, the participants' cognitive performance flatlined.
Flatlined entirely.
Their level of impairment was biologically identical to someone who had been kept completely awake for 24 hours straight.
Oh my God.
And it gets worse. After 2 weeks, their impairment matched someone who had been awake for 2 full consecutive days and nights.
Wait, let me make sure I'm understanding the scale of this. Sleeping 6 hours a night for a couple of weeks degrades your brain to the exact same functional level as pulling 2 back-to-back all-nighters.
Yes. The neural networks responsible for sustained attention and problem solving simply degrade under that compounding pressure of sleep debt.
But wait, I push back on this because I constantly talk to people, Wall Street executives, emergency room doctors, startup founders. They swear they've trained themselves to function perfectly on 6 hours. Are they just genetic anomalies?
No, and we are hitting on what is arguably the most dangerous phenomenon in sleep science here. It's the self-assessment trap.
The self-assessment trap.
Right. Sleep deprivation destroys your brain's ability to accurately assess its own level of impairment. It's a condition neurologists refer to as anosognosia.
Anosognosia. So they genuinely believe they are performing at peak capacity.
Entirely. In the Dinges study, they continuously asked the participants to rate their own fatigue and performance.
Yeah, what did they say?
The people functioning on 6 hours consistently reported that they felt they had adapted. Subjectively, they felt totally fine. But the objective data, the actual measurements of their cognitive reaction times, proved their performance was continuing to plummet.
It's like having a broken fuel gauge in your car.
That's a great analogy.
The gauge reads full, so you feel entirely confident merging onto the highway at 80 miles an hour. But the gas tank is actually bone dry, and the engine is about to stall. You just don't know it.
Exactly. The prefrontal cortex loses the capacity to self-monitor. So when someone tells you they function perfectly on 6 hours, the science indicates they are almost certainly wrong. They just lack the neurological capacity to realize how impaired they actually are.
They feel adapted, but objective data proves they aren't. And the fallout extends way beyond just forgetting a word or, being a little slow on a spreadsheet. The emotional volatility is massive.
Oh, it's night and day. If you look at the research from Matthew Walker's fMRI lab, it exposes exactly what happens to the emotional centers of the brain after just one single night of sleep deprivation.
So what did they do in the lab?
Walker's team put sleep-deprived individuals in an fMRI scanner and exposed them to highly provocative, emotionally triggering images. And they specifically monitored the amygdala.
The amygdala, which handles our primitive, instinctual emotional reactions. It's basically the brain's threat detection center, right?
Exactly. It's your alarm system. And the scans revealed a 60% amplification in the reactivity of the amygdala compared to the participants who had slept a full 8 hours.
60%?
Yes. The amygdala was functionally hyperactive. But the real mechanism of failure was found when they looked at the medial prefrontal cortex.
Okay, the medial prefrontal cortex. That's the logical, rational, executive center of the brain.
Right. It's supposed to sit above the amygdala and act as the brakes. It applies context and suppresses inappropriate emotional outbursts.
It tells the amygdala, hey, calm down, it's just an email, not a tiger.
Precisely. But after a single night of poor sleep, the functional connectivity, the actual neural pathway between the prefrontal cortex and the amygdala, was effectively severed.
Severed, like the signal couldn't even get through.
The regulating signal simply couldn't reach the amygdala.
So you have this over-revving emotional engine, and the biological brakes have been completely removed.
You literally lose the neurological hardware required to regulate your temper and your emotional responses. You are biologically trapped in a state of hyperreactivity.
Bringing this down to earth for everyone listening, this is exactly why relationship conflicts spike after a bad night's sleep. This is why workplace aggression happens over the smallest little miscommunication.
Absolutely.
This is why, if you're a parent, your patience with a toddler's tantrum completely tanks after a rough night. You aren't just in a bad mood. Your brain has been temporarily, structurally rewired to be highly reactive. You literally cannot cool yourself down.
And that emotional dysregulation bleeds into every social interaction you have that day, drastically lowering your empathy and increasing volatility.
Okay, so emotional volatility is obvious to us. We feel that. But what is happening underneath the surface? Because if the emotional and cognitive networks are failing that dramatically, our physiology has to be in crisis too.
It absolutely is in crisis. The "I'll sleep when I'm dead" mantra gets incredibly dark when we look at the immune system.
Because we often view sleep as this sort of passive supportive pillar for health. like staying hydrated or taking a vitamin.
Right, but it's not supportive. It's an active, frontline defense mechanism. The Carnegie Mellon rhinovirus study perfectly illustrates this.
This study is wild.
It is. Researchers literally quarantined healthy volunteers, monitor their sleep patterns for a week, and then intentionally infected them by squirting a live cold virus up their noses.
They just directly expose them to the pathogen to see whose immune system would fail.
Yes, and the results were definitive. The individuals who had been sleeping fewer than 6 hours a night in the week leading up to the exposure were 4.2 times more likely to actually develop the cold compared to those getting 7 hours or more.
Not just a little more likely, 4.2 times more likely. The lack of sleep fundamentally suppressed their immune response.
And it gets significantly more serious than the common cold when we look at oncology and cancer surveillance. The immune system relies heavily on specialized white blood cells called natural killer cells.
Natural killer cells, they act like the secret service of the immune system, right?
That's a great way to put it. They patrol the bloodstream, identifying malignant cancerous cells and injecting them with a protein that destroys them before they can multiply and form tumors.
So they are constantly keeping us safe from cancer.
Yes, but just one night, a single night of restricting sleep to 4 or 5 hours slashes the activity of those natural killer cells by a terrifying 70%.
70% of your innate anti-cancer defense force is just deactivated after one bad night.
Completely deactivated. And the physiological mechanism behind that drop is tied to the sympathetic nervous system.
Because the body thinks it's under attack, right?
Exactly. When you deprive the body of sleep, it perceives that deprivation as a state of acute threat. It activates the fight or flight response. This triggers a sustained release of stress hormones like cortisol and adrenaline.
And that chronic elevation of stress hormones just suppresses the immune system.
It actively suppresses the generation and function of natural killer cells alongside a host of other critical immune factors.
Okay, so our immune system is compromised. What about our metabolism? Because so many people fight this daily battle with weight and diet.
Oh, the metabolic effects are huge.
You know that intense feeling late at night when you suddenly have an overwhelming craving for high-sugar, high-calorie junk food, and you sit there beating yourself up thinking it's a failure of willpower?
I can tell you right now for the listener, your late-night craving isn't a failure of willpower. It is an entire biochemical hijacking driven by sleep restriction.
Because of the hormones.
Yes. When you cut your sleep short, you severely alter the endocrine system, specifically the hormones that regulate appetite and satiety, namely ghrelin and leptin.
Let's break those down.
Ghrelin is the hormone that signals hunger to the brain. When you are sleep deprived, your body significantly spikes the production of ghrelin, so the hunger signal is massively amplified.
Your body is shouting, eat!
Right. But simultaneously, the lack of sleep tanks the production of leptin. And leptin is the hormone that signals satiety, telling your brain that you're full.
So you have a spiked hunger signal and a broken I'm full signal. Your body is artificially starving, and it actively refuses to acknowledge when you've consumed enough calories.
Furthermore, sleep deprivation actually stimulates the endocannabinoid system in the brain.
Wait, like marijuana?
Similar mechanism, yes. It specifically drives a hedonic preference for high-calorie, sugary, and salty foods. You don't crave a salad at midnight on 5 hours of sleep.
No, you want donuts. You want chips.
Your neurochemistry is demanding those things. The sleep-deprived individual is fighting their own fundamental biological hunger regulation with nothing but conscious willpower. And in a fight between willpower and neuroendocrinology, the hormones almost always win.
Which means short sleep is an independent predictor of obesity, right? Regardless of diet and exercise.
Entirely independent. You could be running miles every day, but if you are sleeping 5 hours a night, your biochemistry is actively working to store fat, drive caloric intake, and induce a state of pre-diabetic insulin resistance.
We also have to talk about the daylight saving time data, because honestly, this is the most striking, undeniable proof of how fragile our cardiovascular system is in relation to sleep.
It's an incredible, albeit scary, global experiment. Every year, over 1 billion people participate in this artificial shift of time.
And what happens when we spring forward?
When the clocks spring forward in the spring, we collectively lose 1 hour of sleep. Just 1 hour. But hospital records reveal that on the Monday following that lost hour, there is a 24% spike in heart attacks.
A 24% increase in acute myocardial infarctions, triggered entirely by the loss of a single hour of sleep. That is insane.
And the mechanism works symmetrically in reverse. In the autumn, When the clocks fall back and we gain an hour of sleep, hospitals record a 21% drop in cardiac events the following day.
It is a completely binary population-level experiment. Lose an hour, cardiovascular failure spikes. Gain an hour, cardiovascular trauma plummets.
The acute stress response from losing that hour, the sudden spike in sympathetic nervous system activity, the sudden increase in heart rate and blood pressure, it is enough to push vulnerable individuals right over the edge into a cardiac event.
It just proves that sleep is not a long-term wellness goal. It is an immediate daily biological necessity.
Exactly.
But, if the cardiovascular and immune impacts are happening overnight, we have to ask what the long-term compounding consequences are. Like, people hustle through their 30s and 40s on 6 hours of sleep for decades, treating it as a productivity trade-off. What is happening deep in the brain tissue over that time span?
This brings us to one of the biggest neuroscience breakthroughs of the past decade, the discovery of the glymphatic system.
Okay, the glymphatic system. Let me set up an analogy here. Every other organ in the body relies on the lymphatic system to clear out cellular waste. But the brain doesn't have a traditional lymphatic system.
Right. For a long time, it was a biological mystery how the brain cleared the metabolic trash generated by billions of neurons firing constantly.
So if the brain is a bustling city during the day, generating tons of trash, the glymphatic system is the fleet of street sweepers. But they only come out when the traffic dies down in deep NREM sleep.
That's precisely how it works. During the day, the intense metabolic activity of conscious thought generates a massive amount of protein byproducts and debris. You can't effectively clean the city streets while the traffic is flowing at full speed.
But during deep NREM sleep, the traffic halts.
And something extraordinary happens to the glial cells, which are the supportive cells surrounding the neurons. During deep, slow-wave sleep, these glial cells actually shrink in size by up to 60%.
They physically contract.
Yes, which opens up the interstitial spaces between the neurons. This expansion allows cerebrospinal fluid to rush through the brain tissue in a convective flow.
It's literally a nightly power wash for the brain.
It washes out the metabolic waste products that have accumulated during the day, flushing them back into the circulatory system to be disposed of by the liver.
But the specific waste products being cleared away, that's where the narrative gets chilling. Two of the primary proteins washed out by the glymphatic system are beta amyloid and tau proteins.
And anyone familiar with neurodegeneration knows those names. The abnormal accumulation of beta amyloid plaques and tau tangles in the brain tissue is the definitive biological hallmark of Alzheimer's disease.
So when you chronically deprive yourself of sleep, you are keeping the street sweepers in the garage.
You are preventing the glial cells from shrinking and the cerebrospinal fluid from washing the brain. The beta amyloid proteins begin to accumulate and stick together, forming these plaques.
And it becomes a vicious compounding cycle, right? Because of where those plaques build up.
Yes. They specifically aggregate in the deep sleep-generating regions of the brain first.
So the lack of sleep causes the toxic proteins to build up, and those toxic proteins directly damage the exact brain regions required to generate the deep sleep needed to clear them out in the first place.
It creates a self-perpetuating downward spiral. This raises a really important question for that middle-aged professional working late nights on 6 hours of sleep. They might think they're being productive, but they are actively inhibiting their primary mechanism for clearing the neurotoxins associated with cognitive decline.
They are setting up a biological cascade that may not manifest as severe memory loss for another 20 or 30 years.
But the damage is compounding every single night.
Okay, I think we've thoroughly terrified everyone with what a lack of sleep does.
Well,
Let's pivot the mood a bit.
probably a good idea.
Let's talk about the incredible cognitive superpowers we gain when we actually prioritize it, specifically regarding learning and memory. Sleep is essentially the ultimate cognitive hack, right?
It absolutely is. When analyzing the neurology of learning, we categorize sleep into two distinct requirements: the sleep you need before you learn and the sleep you need after you learn.
Let's start with the sleep before learning. This prepares the brain's memory center, the hippocampus.
Right. Think of the hippocampus as the inbox. It's a fast-learning but low-capacity sketchpad.
It's like a USB drive. Once it's full, you just can't save any more files until you dump them onto your main hard drive.
Exactly. Throughout the day, as you experience the world and learn new things, you are temporarily writing all that data onto this USB drive. But because it has a finite capacity, it eventually fills up. If you don't sleep, you can't clear the drive. Any new information you try to absorb simply bounces off.
And there's data to back this up, right?
Yes, Matthew Walker's lab demonstrated this capacity limit brilliantly. They took two groups of people and tasked them with learning a massive, rigorous list of new facts. One group was kept awake all day. The other group was instructed to take a 90-minute afternoon nap.
And that nap specifically included deep NREM sleep.
Right. And the group that took the nap improved their subsequent learning performance in the evening by 20% compared to the wake-only group.
A 20% cognitive advantage just from taking a nap and clearing the USB drive.
And the mechanism doing the clearing is tied to those slow brainwaves we talked about earlier. During deep NREM sleep, the brain generates powerful electrical signatures called sleep spindles.
Sleep spindles.
They act as a file transfer mechanism. They physically move the newly acquired memories from the temporary storage of the hippocampus up to the permanent, massive capacity storage vault of the neocortex.
It secures the memories while simultaneously emptying the hippocampus, giving you a fresh, blank sketchpad for the next day. Okay, so that's sleep before learning. But the sleep required after learning is just as critical.
Oh, absolutely. Sleep after learning is the neurological save button. Information is significantly better retained, and the neural pathways are actively reinforced if you sleep shortly after acquiring the knowledge.
And this is especially true for motor skills and procedural memory, right?
Very much so. Consolidating physical procedures, like playing a piano scale, swinging a golf club, or even mastering the mouth movements and pronunciation of a new language, that specifically happens in stage 2 NREM sleep.
And when does that stage happen?
The highest concentration of this specific sleep stage occurs in the final 2 hours of the night.
Okay, so direct advice for you listening right now. If you are practicing a new language, the vocabulary, the grammar rules, the pronunciation you review before bed, those are physically integrated while you sleep. The brain is actively replaying the sequence.
Yes. But if you cut your sleep short and wake up at 5 a.m. instead of 7 a.m., you are amputating the exact phase of sleep that acts as the save button for the physical skills you spent hours practicing the day before.
Sleep is not recovery from learning. It is a phase of learning.
I'll say that again because it's so important. Sleep is not recovery from learning. It is a phase of learning itself.
That's a massive paradigm shift. But, if sleep is the foundation of learning and health, why is our society seemingly designed to ruin it?
That's the tragic irony of modern life.
Let's talk about individual variation in sleep timing, because the standard 9-to-5 schedule is a massive biological injustice.
It really is. We have to look at chronotypes. A chronotype is your genetically influenced tendency for sleep-wake timing. It is heavily influenced by a specific set of genes called the PER genes.
The biology of larks and owls.
Right. Morning types naturally feel alert early in the day and become sleepy in the early evening. Evening types naturally peak in cognitive performance later, in the late afternoon or evening, and deeply struggle to function in the early morning.
And how is the population distributed? Because we treat everyone like they should be a lark.
Research by chronobiologists like Till Roneberg shows that it's distributed pretty evenly. Roughly 1/3 are morning types, 1/3 are evening types, and 1/3 fall into an intermediate zone.
So a third of the population are naturally owls, and the gap between the extremes can be huge, up to 6 hours.
Yeah, a strong lark might naturally wake up at 5 a.m., biologically primed and ready to go. Meanwhile, a strong owl's biological sunrise, the moment their brain actually begins producing wakefulness signals, might not occur until 10:00 or 11:00 a.m.
Which means the standard 9-to-5 work schedule perfectly suits larks, but it forces owls to do deep cognitive work at their biological equivalent of 3:00 a.m.
Exactly. It induces a state of chronic circadian misalignment. And the epidemiological data shows the consequence of this. Owls suffer from significantly higher rates of depression, metabolic disorders, and cardiovascular disease.
But we need to make it clear, not because being an owl is bad or unhealthy.
No, not at all. It's because of the chronic circadian misalignment. Society forces them to live constantly out of sync with their own biology. Their brain prevents them from falling asleep early, but the societal alarm clock forces them awake early regardless.
And this chronotype conflict is most acutely visible when we look at teenagers. Let's debunk the myth of the lazy adolescent.
Yes, please. The cultural myth of the teenager who refuses to go to bed and won't wake up for school is entirely divorced from biological reality.
Because during puberty, their circadian clock shifts drastically, right?
It undergoes a massive phase delay. The biological timing of melatonin release shifts drastically toward the evening.
So here's where it gets really interesting for parents listening. A 15-year-old physically cannot fall asleep at 9:30 a.m. Their suprachiasmatic nucleus is actively suppressing melatonin and keeping them alert.
Right. So asking a teenager to wake up at 6:30 a.m. to catch a bus is biologically equivalent to asking an adult to wake up at 3:30 a.m. every single day to absorb complex calculus.
They aren't lazy, they are battling their biology.
And when school districts actually align with the biology and delay start times from, say, 7:30 a.m. to 8:04 or 9 or 0:00, the outcomes are universally spectacular.
Academics improve, right?
Objectively improves academics, lowers depression, and crucially reduces teen driving accidents because they are no longer operating vehicles in a state of catastrophic sleep deprivation.
Okay, so you listening now understand the why. You know how crucial sleep is. So how do you practically apply this to your life starting tonight? Let's go over some evidence-based interventions.
The absolute foundation of sleep hygiene is establishing ruthless consistency. Consistency is king,
Waking up at the exact same time every day, even weekends.
especially weekends. Waking up at the same time is the most critical intervention to anchor your circadian rhythm.
But the natural tendency is to assume that if you shortchange your sleep during the work week, you can just sleep in on Saturday to catch up.
And while sleeping in does pay down a portion of the accumulated sleep debt, it introduces a highly disruptive phenomenon called social jet lag.
Explain social jet lag.
By waking up 3 hours later on Sunday morning, you have effectively dragged your internal master clock 3 time zones west. So when Sunday night arrives, your body clock believes it is 3 hours earlier than the actual time. You physically cannot fall asleep.
You essentially flew from New York to California for the weekend, biologically speaking, and then Monday morning hits like a truck.
Exactly. Consistency prevents this massive oscillation.
Okay, intervention 2, temperature manipulation. The recommendation is to keep the bedroom cool, around 65 to 68 degrees Fahrenheit, or 18 to 20 degrees Celsius.
To initiate sleep, your core body temperature must drop by about 1 to 2 degrees Celsius. A cool, ambient environment facilitates that necessary drop.
But wait, if we need our core to be cold, why do people universally recommend taking a hot bath before bed? Applying external heat seems completely counterintuitive to lowering internal temperature.
It's a fascinating paradox. The mechanism is a brilliant biological trick involving vasodilation.
Vasodilation.
Yes, when you immerse your body in hot water, the blood vessels in your extremities, your hands, feet, and the surface of your skin dilate massively. All the blood rushes to the surface to dissipate the heat.
So you step out of the bath and you're radiating heat.
Right. And as you step into a cool bedroom, that massive surface area of dilated blood vessels acts like a radiator, rapidly venting heat away from the center of your body. Your core internal temperature actually plummets precipitously.
Wow. And that rapid drop in core temperature is the signal to the brain that it's time to sleep.
Exactly. It's a highly effective thermal hack.
Next lever, light.
Morning bright sunlight within the first hour of waking is a powerful Zeitgeber, or time giver. It halts melatonin, boosts alertness, and sets a timer for sleepiness later that night.
But then evening blue light does the exact opposite, right?
It suppresses melatonin. Bathing our eyes in the blue light emitted by screens late into the evening actively deceives the brain into thinking the sun is still up.
So dim your screens, dim the ambient lighting in your home a couple of hours before bed. Just don't blast your eyes with fake sunlight at 10 p.m.
Right. Now we have to talk about the chemical saboteurs, caffeine and alcohol.
Let's start with caffeine. It's all about the half-life.
It is. Throughout the day, as our neurons burn energy, a metabolic byproduct called adenosine steadily accumulates in the brain. It builds up sleep pressure.
And caffeine essentially blocks that.
Yes, caffeine operates as a competitive antagonist. Its molecular structure is so similar to adenosine that it docks into those exact same receptors, blocking the adenosine from binding. The brain is still exhausted, but its ability to measure its own exhaustion is chemically muted.
But the half-life is the real kicker here. It has a 5 to 7 hour half-life.
Which means a 3:00 p.m. coffee means 50% of that caffeine is still active at 8:00 or 10:00 p.m.
Even if you fall asleep fine, it's quietly destroying your deep NREM sleep architecture. So that afternoon coffee is literally preventing your glymphatic system from washing your brain properly.
Precisely. And then there's alcohol, which might be an even bigger misconception.
Because so many people use a nightcap to sleep.
Alcohol is a central nervous system depressant. It provides sedation, not restorative sleep. You are basically medically knocking yourself out.
And it wrecks the actual sleep cycles, doesn't it?
Completely. The metabolic processing of alcohol fragments your sleep, causing you to wake up repeatedly throughout the night. More importantly, alcohol decimates REM sleep. It is one of the most potent chemical suppressors of REM sleep we know of.
So you are actively preventing your brain from processing emotional trauma and consolidating memories?
Exactly.
As we wrap up, we really need to look at how we frame sleep culturally. I want you, the listener, to confront your own potential biases against sleep. The idea that you're getting ahead by staying up late.
The empirical reality is that the extra hour of work done on 6 hours of sleep is inherently lower quality than the same work done on 8 hours. The compounding cognitive and health tax just dwarfs any short-term perceived productivity.
If sleep is for the weak, why do the strongest people on the planet prioritize it? Look at elite athletes.
LeBron James sleeps 10 to 12 hours a night. Roger Federer sleeps 11 to 12 hours during tournaments.
Elite sports teams now employ dedicated sleep coaches because they know sleep deprivation destroys reaction times and skyrockets injury risk.
The final paradigm shift is this. The person who sleeps enough isn't losing time. They are cognitively sharper, emotionally regulated, and fundamentally outperforming their sleep-deprived competitor. Sleep is the foundation of performance, not the enemy of it.
It is the ultimate cognitive enhancer. Thank you for fundamentally changing how we look at the third of our lives spent with our eyes closed. We've traced the entire mechanism today, from the glymphatic street sweepers preventing Alzheimer's to the sheer injustice of the early morning alarm clock for an evening chronotype.
We spend so much time optimizing our waking hours, right? Our diets, our workouts, our to-do lists. But what if the ultimate life hack isn't doing more while we're awake, but finally respecting the biological mandate of what happens when we're asleep? Next time you set an alarm that cuts your night short, ask yourself, which critical maintenance process in your brain are you choosing to hit cancel on tonight?
That is the thought I want to leave you with. Next time you reach for your phone to set that alarm, ask yourself what you're canceling. Tonight, treat yourself to a deeply restorative, unapologetic 8 hours of sleep. We will see you on the next deep dive.